Okay, the problem is number of ways to assign age weights. Okay, the problem is very simple, but it is very many things are actually added into this problem. Multiple things are added. You have to. This is very conceptual, so it will be very lengthy. First, start what the problems in. There is an undirected graph with n nodes labeled 1 to n. So, a level of node is starting from 1 to n, not 0 to. The first thing you have to remember this one. Root node is always 1. So, by default, this root, if it's a tree, this is always 1. Root node is always 1. So 3 is represented by a 2D integer array of ages of length n minus 1, where ages I is ui vi indicates that is the age between nodes of u and v. So let's give you an example. This is root node, let's say 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Let's say this is our case. Okay. So our what will be the ages? Ages will be like on 2D integer array. So each age having having n minus 1. Why n minus 1? So this is a property of a tree. If tree has n node, first of all, it's a tree, not a graph. So if tree has a so as it is a tree, not a graph, then that is no cycle. Like tree doesn't have the cycle. Tree is special. You can think of tree as special kind of graph. Doesn't have the cycle. Then you can call that graph as a tree. Okay. So it is given. So why n minus 1? So if it is a tree and it's a connected tree, then there is it is a property. If there are n nodes are present, then a number of ages will be n minus 1. See how many nodes are present? 8 nodes are present. How many like ages are there? 1, 2, 3, 4, 5, 6, 7. It's always a property of a tree. Like if tree having the n nodes, number of ages is n minus 1. That's why length of ages is n minus 1. So there is only n minus 1 ages are there. So if I perform one thing here, like if I perform the ages, what are the ages will be? It may be 1, 2. It could be 7, 5, 7, 5, 7, 5 because of this one 7, 5. It could be in any order, right? It could be let's say 8, 6. It could be 2, 5. It could be 3, 4, and it could be 4, 1. So these are the ages. So it could be in any order. So these ages are there. Okay. So that is done. So what is actually have to do? So now ages is initially weight is 0. So all age have weight of 0 initially. Now we have to assign a weight. We have to assign a weight either 1 or 2. So it will be 1, it could be 2, it will be 1, it is up to your choice. Like what are the weight you are going to assign it. We can assign any weight for it will be anything. So cost of the path, let's say the cost of the path between u and v, the total weight of the all ages connecting to them. Let's say I am doing one, let's say putting 1 here, 1 here, let's say 2 here, 1 here, and 2 in this place. If I do, and let's say what is the weight of this from 1 to 7. Let's say what is the weight of this from 1 to 7. What is the weight? It will be like what is the cost? Sorry, not weight. What is the cost of that? Cost is the sum of all the weights between present in this two nodes. The path present in this two nodes. So the path is this is the path. Okay. What is the cost? Will be summation of all weights present in this path. So summation is 2 plus 1 plus 1. That is 4. If I find this way like 1 and 3, what will be the cost of this path? Cost of this path is 2 plus 1 3. This is how we can calculate the cost. Still now I guess you understand what I am going to say. Okay, now select any node at x at maximum depth. So what will be the maximum depth? As I have having the longest path. The longest path is nothing but this one and this one. You can choose any of them. Like longest path is any node present in the maximum depth. So what are the nodes present in maximum depth? 7 is present, 6 is also present. You can choose any one. I can choose 7, I can choose 6, doesn't matter. Why it doesn't matter? We'll see. Return the number of ways we can assign the weights in the path from node 1 to x. X is a node I'm choosing in the maximum depth. So I'm choosing, let's say this one. I'm choosing this thing. So we have to return the number of ways assign the ages. So we can put it 1 here, 2 here, 1 here. Then I can put like 1 here, 2 here, and 2 again here. I can put it like 2 here, 2 here, 2 here. Like these are the ways we can assign the number. But the thing is, one condition is there. You have to return the number of ways to assign the age weight in the path from node to x such that the total cost is what. So at the at any I can assign any way, but overall cost would be the odd. So I cannot assign 1, 2 and 1. If I assign it, the cost becomes 4. So either I have to choose 1, 2, 2 or something like you have to do 1, 2, 2. So then it becomes cost becomes odd. Okay. So this is what we have to do. Now why did they say like any node x? So see here, any node x means if it's the maximum length, so what is the paths? How many edges are present in this path? That will be the same. You can choose this one, you can choose this one, doesn't matter, because number of weights present, or you can say number of edges present in this path will be the same. So maximum length means the length is the number of what should I say, number of edges is actually your maximum depth. See here, what is the depth of this 7? 3, right? First, second and third. So what is the, how could I say, the number of edges present in this is the number of depth, correct? So this is how we can say, like we can choose anyone, we can choose this one, doesn't matter, because here also number of edges are same. So now my problem is like return the number of ways we can get it. Okay, we can return the number of ways we can assign the age weight. Okay, so that whole cost is odd. Okay, fine. Okay, let's finish the problem statement. Since the answer is very large, so return modulo 10 to the power 9 plus 7. Fine. Ignore all edges, not the path from 1 to x. Ignore all the edges, not in the path from node 1 to x. So if I am choosing this one, I can ignore these all things. I just have to assign what are the present in the edges present in this path. I have to assign it. Okay, and what is the constant? N could be 10 to the power 5. Edges length is obviously n minus 1. Edges ui vi. This is the thing. Edges represent the valid tree. It's a valid tree. It is given. It's a valid tree. Okay, fine. So first thing is, my first problem is to find the maximum depth. First problem is find the maximum depth. So from the problem statement, what is my first task will be? First task is find maximum depth. This is my first task. Then what are the next tasks is return the number of ways we can assign the edge value. Second task is right total number of ways, the number of ways to assign the edge weight. So the number of ways to assign edge weight. Okay, so these are the two things I have to do. First, we have to find that this depth first. Then I have to find the number of ways we can assign edge weight. Okay, for if you know the thing, if you know the graph or tree, let's see here, as I told you, and another thing before that also, zeroth step will be form the tree. So first you have to make the tree, then only you can find the depth, right? First, the thing is, forming a tree will be much difficult. See here, forming a tree in the difficult, because it could be any order, I could say it, right? So it could be any order, it could be possible. So if you remember a couple of days earlier, there is a problem to create a binary tree. Okay, so this is that approach we can follow, like hash map we can follow, and then create a tree. So do I actually need to create a tree? Is it, do I really need that thing? Think of it. It is nothing but a graph, isn't it? Even if it seems like a tree, but it is a graph as well, right? So it's a graph as well. So as I told you, tree is a kind of subset of a graph. Tree is a special kind of graph where the cycle is not present. So you can say definition of tree this way as well. Like if it is a kind of a graph, if the graph doesn't contain a cycle, it is a tree. So now think this thing not as a tree, think as a graph. So now from graph, if I need to know what is the longest path present in the graph, then what is the easiest way? What is the like formal way? We can do the DFS. DFS is mostly used to find the longest path present in the graph. Okay, so we can say like right now we will not form a tree, we will form graph. So this is updated. My problem, like my target is updated. Okay. So we can form the graph first. So form the graph, what we need, one set of this is given. So we can form simply adjacent list. Adjacent list, like from 1 where can I go? I can go 2 and 4. From 2 where can I go? To go 1 and 2 to go 5. Then 4 where can I go? I can go 3 and 8 and this kind of thing. So this way we can create an adjacent list, correct? So for this, to create a graph, so we are using the adjacent list. Adjacent list, we are going to form adjacent list so that we have a clear view, like from one node we can go to which nodes, we have a clear view for that. So that we could do. Next step is like find the maximum depth. So as I told you, like finding the maximum depth. So what is the like what should I say, what is the formal way to find it? Formal way to find this thing is to using the DFS. We use DFS to find the maximum like longest path. So nothing we need for the longest path. So that for using that, then we will use DFS to find the longest path. That's all. The second problem is also done. Now the third solution, number of ways to assign the age width. Okay. So let's say I am saying, let's say my longest path is X. Okay. So longest path X means the number of edges present in the path is X, as I told you. So maximum depth is nothing but number of edge present in that path. So I have to say the maximum depth. So what can I say in other way? What can I say? A maximum number of edge present in that. So let's say maximum number of present is X. So X, here it is 3. See, here it is 3. So here it is 3. So 3 3 3. Sorry 1 2 3. So it is a 3. So it could be anything. So that's a let's say X. So if I say it is X, then how many ways I can assign it? How could we do that? Okay, there's a simple formula. I will explain the formula later, but for that, like if it is a X and number of age is present X, and I have to assign such a way it can only contain my odd number, the sum should be the odd number, then what could be the formula? Formula will be 2 to the power X minus 1. I will explain the formula, but if you don't want to know the formula or explanation, you can skip the video. But the formula is, if my path is X or number of edges present in the path is X, then how many ways we can assign the edge weight such that my overall cost, the cost is nothing but sum of all the edges, overall cost is odd. So that formula is to deliver X minus 1. X, here X is nothing but number of edges present in that path. Hope still now you get everything. Okay. Now I am going to explain how we are getting to this formula. How we are getting this formula. So if you don't not want to know this formula, then we can skip the video. Something I don't know. It will take me 5 minutes or 10 minutes to skip. So just do the skip. Okay. Let's start. Okay. I will say like how to do this thing. Okay. Fine. Let's take a image. Okay, let's explain the formula. Let's say my longest path is 3, like 3 edges present. So 3 edges are there. Okay. Now I have to assign such a way so that my summation is odd. So if 3 is there, any odd number is there. So how many way, like total number of places is 3. Now I have to do such a way so that count could be total sum could be odd as well. So what is the way? So if I put 2 odd digit here, then doesn't matter if I put 2 here, then it is not a possible. So in a simple word, if I say 2, so in a series of number or in a collection of numbers, the sum could be odd if and only if number of odds present in the number is also odd. This is the simplest way you can think of it. So the thing is, what I'm saying, if number of, like here 3 places are present, so here numbers should be 1 and 2 only. There's no other numbers. So but I want my summation of that whole numbers. What I can choose, I can pick 1, I can pick 2, doesn't matter. But the sum should be my odd. So what is the formula? I have to choose either 1 here, then I can pick 2 here, I can pick 2 here, 2 here. Or what can I choose? I can choose 2 here, 1 here, 2 here. But how can I choose here? 2 here, 2 here, 1 here. So what I am doing, among three places, I am picking only one odd number. Okay. So this is nothing but 3C1. Got it? Okay. Is there any other way? I can choose like summation should be 1. Yes, there is another way. This another way is nothing but 1, 1, and 1. All three. So this 3C3, three places is there. Among all the three places, I am choosing three place, like from overall place. How many place should be the odd? This is the thing. So overall place is 3. All three I am choosing as odd. That's why it is 3. So this is 3, 3, 3, 3C3. So what is the number of ways we can do this thing? 3C3 is 3 plus 3C1 is 1. That is nothing but 4. So let's say it is not 3. Let's say it is 5. How many ways we could do that? So if it is 5, let's see here, like I can choose only 1 here, 2, 2, 2, or there are all possible cases, 2, 1, 1. I can choose only 1 and many 1. So that is nothing but 5C1. Okay. So I can choose this thing, or what can I choose? I can choose, instead of choosing only one place for odd number, I can choose 2 place for odd number, 3 place for odd numbers. This is I can choose, or I can choose 3, 1, 1, 1, and 2, and so on. Correct? We can choose this thing. So among 5 places thing, how many place I want to choose as an odd number? Like 3 places. So as I told you, if collection of numbers is there, this collection of number is there, I want this collection of number of sum should be my odd. So what is the way we can do that? So number of, like there is integers are there, right? These integers are there. So total number of integers, like if I do the sum of these integers, this should be odd. So what is the, how could we achieve that? To achieve that, the number of integers of which are odd, that should be also present in the odd number. What I'm saying, I want to say, like how many odd numbers are present here? Let's say odd numbers contribute to odd. See, odd numbers, if we take 2 odd numbers, 2 odd, it is nothing but even. Okay, only one odd is nothing but a odd. If it is a 3 odd, so 3 odd numbers are there, 3 odd number are there, then also it is odd number. Correct? So number of odd numbers should be odd. If you get it, doesn't matter how it is 2 is there, so it is 1, 1, 1. How many times it is 2, 2, 2? Number of odd numbers is odd, so it is fine. So let's say it is only 1. Let's say others are 2. Even though numbers of odd number is 1, so it is fine. So let's say 3, 4, 5. Now it is 2. Now number of odd numbers is 1. I cannot put this one as a 1 because then it will create, like, what should I say? It will becomes an even number. That is the thing. The number of odd numbers should be 1. So okay, so come back to the example. I'm checking 5 place. So 5 place is there. And now what can I do? I can take, like, from 5 place, I can take 5, all the 5 number of numbers odd. So all the 5. So this is the one thing. This is how can we calculate. Okay. Okay. Next, my thing is, let's say it is nothing. It is not a, now 4 places are there. So same thing, 4 places are there. 4C1. I can choose among the 4 places. I can choose any one place for the odd number. I can choose any 3 places for the odd number. Why I'm saying plus? Because number of odd numbers should be odd. So, and again 4C5. 4C5 is not possible. So these 2 cases are possible. So this is a way I can calculate. Okay. So there is a common thing, like if that is nothing but say n places are there. So what can I choose? N places. NC1, then NC2, then NC3. Sorry, not NC2. NC3, NC3, then NC5, then NC7, and such that so on goes on. So this is nothing but 2 to the power n minus 1. Okay. So I guess you are getting it by taking to the power n minus 1. This is how you can get it. Now, to know how it becomes 2 to the power n minus 1, now I am not going to explain that thing because it's a mathematical expression. You can explain, but this is you think as a formula. But if you want a proof of this formula, then please go, like, you can ask GPT, Copilot, Gemini, anything, and Claude, everything. How would you get this summation is becomes. It is very easy way you can also learn that. The mathematical proof is there. Okay, so hope you get it. So this is nothing but 2 to the power x. This is x is there. This is 2 to the power x minus 1. This is number of edges. Okay, hope you understand. Okay, now let's take the example. So now we have to create one adjacency list as well. Adjacency list. So, and after that we will use the DFS thing. Then we can assign the edge weight. As simple as that. Hope you got it. So let's start with the problem. Let's say function assign weight. Okay, what is given? Ages are given. That's all we have. Okay, let's start. Okay, we need one. You can use list of list, or you can use the hash map. I'm using hash map for finding the adjacency list. So this is nothing but I am writing as ADJ, adjacency list. This is nothing but a map of what? Integer and what? List or vector. You can think of it. So it is nothing but that. Okay, fine. So this is the map of what I'm going to create. So now what happened? I will iterate each and every edge, and I will add in the adjacency list for edge in edges. So each edge has two things, u and v. So let's say u equals to edge of 0 and v equals to edge of 1. So u v are there, correct? So I'll simply do this thing. If my edge is not present in the adjacency list, so if my u not present in the my map, right? So u not mp dot find. Let's say my u is not present. I'll do what? I'll simply add this thing as a empty list assign thing. Assigning means I'll do mp of u will nothing but one empty list, correct? Or you can say, let's say array list of integer. You can say here, like, for I'm writing a kind of pseudo code, so don't say array or list, it is fine. So list of integer, this is what we are, this is my map, and in empty list what I am doing, I am writing this thing. This will be my list of integer. Similarly, I have to check for this one as well. If my v is also not present, map.find v. If it is not present, then also I'll write the same thing, mp v equals to list, one new list, empty list, and integer, list of integer. Now I am going to assign the values. Assign the values means, if it is, that means it is present right now. If it is not present, then I am adding it, otherwise it is present. So mp of u dot add, in there I will add v here, and mp of v I will add u here. Got it? So this is how I can calculate my adjacency list. Okay, now adjacency list is completed. Okay, now first step is done. Like, I have created my graph. Graph is done. The first step is my completed. The second step is find the maximum depth. If I calculate the maximum depth, I will use DFS. You can use BFS as well. It depends. You can use DFS or BFS, anything. I can use DFS. So in a DFS, when we do, we usually take visited kind of array, so that it's not visited kind of that. So but thing is here, visited is not required, because see what we have adjacency list and there is no loop is present, so it is not visited, it's not required. So what we have to take, we have to check like uh, let's say create BFS. So DFS, the DFS, what can I do? I can simply call the DFS here. So DFS, I will call the DFS, and DFS will return me what? Maximum length. So let's say max length, maximum depth, max depth is nothing but I'm calling DFS, which will return that. What I have to pass? I have to pass my adjacency list, correct? I have to pass my adjacency list. Now after that, what I have to pass? I have to pass 1. Why 1? 1 is nothing but my parent. Right? 1 is nothing but my parent. Sorry, not parent, my root. Root of them. And after that, what I have to pass? I have to pass 1. Let's say 0. That means this is the parent of 1. As 1 is the root, its parent is nothing. So 0 doesn't exist in my calculation because all nodes are numbered at 1 to n. So 0 doesn't exist. So you can use -1, you can use 0, doesn't matter. And another 0, this 0 is giving you the maximum, like current length, like current depth, or current depth of the current node. So this node is current depth is 0 for node 1. So okay, so this is the my maximum, the DFS function I'm calling. Now let's see how could we calculate my DFX. Like let's write a code for DFS function. Okay, let's see how could I write the DFS. Okay, let's say find, like not function, let's say DFS. What is given to us? Adjacent, what my current node, let's say X, what is that parent of that node, and depth of this node. So I need maximum depth, right? So I'm assigning this a maximum depth. I don't know it, like this depth could be the maximum depth, or what could I get in the future if I go in future, that could be also a maximum depth as well. Okay, that means what I meant to say, let's say currently we are at this position, so I can go to left side, I can go to right side. Okay, so right side, maybe there are 3 things are there. So I am doing what? I am coming here with a depth, let's say X. It will go there, it will take return me +1 case, it will becomes X +1. For now my maximum, that is X +1. But when I visit this side, then I will get 2 things, like +2. So that's one X +2. Correct. So that will be maximum depth. So maximum depth could be my current depth, or I can get better maximum depth. Okay. So what I'm going to do right now, I will iterate for each and every case. So for each v, present it adjacent of what? Adjacent of X. Okay, so each vertex is adjacent of X. I am iterating. Think of it. The one thing, if 1 is connected with 2, my adjacent matrix will be like this one, 2, and maybe many others is there. But 2 also, it is 1. So there is only one cycle is there. Okay, but see here, I know like whenever I'm calling, I am passing the parent as well. So let's say I'm calling from 1, and then I'm calling for 2. So for 2, what will be the parent? Parent will be 1. So yeah, I will simply check here if my X, sorry, not my X, my V, my next target, my next vertex, which is adjacent to the correct case. So right now we're calculating for 2. Okay, so for 2, maybe there are 3 is there as well. Consider there is another one, that is 3. So what will be the adjacency list? 1 and 3. but what is the parent of 2? That is 1. Okay, parent of 2 will be 1. So what I will do, I'll iterate for each case. I will iterate for each case, and I will see whether what are the cases are present. Cases are present means like adjacency, like what are the adjacency nodes of 2. Adjacency node of 2 could be 1 and 3, but 1 is the parent of 2 because from I got came at 2 from 1. So adjacency, like, that's why 1 is the parent of 2. So I cannot go back to 1. I can go to 3, but it is not my adjacent. For 3, 2 will be the parent. That's how we have to. So I have to check if my v is not equals to my parent, then only I can forward to it. So what I will do in that case, I can get a maximum depth and directly write this line. Maximum depth will be maximum of current maximum depth, md, current maximum depth, or I can call DFS. This is DFS. In the DFS, what I can call adjacency matrix. My next vertex, I can go V. What is the parent? Parent of will be X. And what is the depth? Current depth plus 1. I can do that. This is my calling the DFS function, right? This is the calling of DFS function, and this is the end of the maximum function. That's all we have to do, because simply we can write, if you get confusion, I can get one, let's say one length. One length is nothing but I'm calling DFS. And DFS, how could I call? Adjacency matrix I have to pass. The vertex next what I'm going to do, that is nothing but V. What is the parent of that vertex? That is current vertex X. Now what is the length, depth of that? Depth will be the current depth. I can go that vertex, so plus 1. This is the thing. Now this may update my MD. So MD is the maximum that I am getting still now. Maximum that is nothing but maximum of MD. What is the current value of MD? Or it could be the I get from the length. So as I give you an example, this one. So for this one I can get, let's say depth is 2. For this node depth is 2. This one it becomes 3. But this one, for if I go this path, I will get 5. Correct? 2 plus 3, sorry, not 5, 4. So that is the 4. So that's the reason I will do like MD, maximum of MD or length, current depth. Okay, that I could do, or you can say current depth. That will be a good name. Current depth. I'm saying current depth. You can write this thing, and at the end, what I have to return, I have to, let's finish this thing, so otherwise it will be more confusing. Okay, this is also done, and return maximum depth I can return. That's all we could do. Fine, I guess you get this thing. So this is a DFS we could do to find the maximum, like get the maximum length or maximum path. So now maximum path I got the maximum path as well. Now what will be the next approach? Next approach will be this one. Next solution is this case. Next I have to find this, let's say maximum, like find the maximum that I got it. Now return number of ways to assign the edge weight. So this is a simple formula to resolve x minus 1. So you can right now think of it like we can simply write I get the maximum depth. So I can simply return. So that is the maximum that is number of edges. So we can simply return 2 to the power max depth minus 1. We can simply return this thing. Okay, but there is a problem. I cannot simply return this thing. Okay, if you're in a Python, then you can return directly. Python doesn't have this kind of thing. Okay, and mod, that modulo value, that is nothing but my 10 to the power 9 plus 7. So this is the mod. You can return, because I can simply return this thing. In Python you can do this thing. Yes, in Python you can do, but in other case you cannot do this thing. See here, because see the length is 10 to the power 5, and my tree could be this, right? this. So what will be the maximum date? It will be 10 to the power 5 minus 1. That many edges may present if it is only single tree, like linear tree kind of that. So it is into this many depth is possible. And 6 is very huge. If you do 2 to the power 10 to the power 5 minus 1, it will give you, like, it is not possible. Like, it is not possible to do this. And how could you do in the Python? Python is a very special language, you can say. Python it is possible, but other language is not possible. So I have to calculate this power. I have to calculate this power. So simply what can I write? Instead of return directly, I can write power function, let's say, passing 2, because 2 is our base. And what is my exponential? Exponential is nothing but what is I say? Exponential is nothing but my that max depth minus 1 is my exponential. Let's write this exponential function. So let's say power is nothing but just a minute. So in the function power, what is given in the function power? It is given first is my base and my exponential, and by which I want to do the power. Okay. So how would I do? So I can simply run a for loop, and there is a special thing for the modulo. You can do modulo at any time. It will not change any problem. It will not change any problem. So what I have to want to say, let's say, let me tell you. Let's write an integer. Let's say int result. Why I'm writing int? I'm not in the pseudocode. We don't write int kind of this until or unless it explicitly mention what the data type is. So what I'm writing, I want to say, okay, let's say result. I'll store my result into this array. Result is nothing but my 1. So here you should take long. You can like it for the safe side. It would be long. Later we'll return like a integer type question. Okay. For this I'm writing for Java and C++. I'm writing this kind of code. So let's say it's a long result equals to 1. I can write like that loops like for not this one, just a minute. Yeah, for how many times I have to run? For I equals to 0 or I equals to 0 to I less than my exp I plus plus, that many times I have to multiply. Okay, so that many times I have to multiply. So result becomes result equals to result into array. It is lagging. Result into base, and before doing that I will simply do the mod. So mod I have to initialize. So mod is nothing but 10 to the power this thing. So another long, let's say mod. This is nothing but 10 to the power 9, 10 to the power 9 plus 7. Okay, so I will do this mod, and then I can simply return that. So simply return the result. Return the result. Okay, this is the my power function. So right now we can think like this may work, and I don't know it will work or not, but the thing is, to calculate this thing has a time complexity of big of n, because exponential becomes what, as I told you, it becomes 10 to the power 5, right? 4 into 10 to the power 5 or something. It could be exponential of that, a big of 1. But the thing is, we can do this using the log n. using the log n. You can solve the problem using the log n. So this is one power function you could do, or you can use another approach. Let me write that approach as well. First, I will write the approach. Then I will explain the approach. Why I am doing that? The video is going to be larger because I have to explain again that topic. So if anybody, you can understand, you can remember this formula as well, because it's a kind of a nothing but a formula you can use in future. So if you don't want to understand how this approach is going on, you can simply write this formula, because it is like calculating power is not a our main focus. We know what is the logic and we understand. So if you rightly just use the formula, you can use the formula. That's why I'm writing the formula first. Then I will explain the how could I get the formula. Okay. So for that, what I need again that power is needed. But right now, what is the power is there, and I need the mod. I should remove that mod one. So this is long is nothing but my that mod is nothing but 10 to the power 9 plus 7, and another thing is there. So let's say long is my result, that is also 1, and another one I need long, let's say base. Long, let's say base is nothing but let's say base is this base, or I can write, let's say it is x. This is, let's write this as x, and let's say base. Like for me it will be easy to explain later, so that's why I'm writing this like base is x. Okay, now the formula is like this. So while uh, let me also write, instead of exp I'm writing as y, so it will be easy. So while y is a valid number, I'll do if, I'll explain in a little bit why this is happening. This is a bitwise AND. If that is the case, modulo mod, after that we have to like reassign the base in the sense base becomes base into base division by mod, and okay, to remove this one as well, then I have to again write one y, write shift by one digit, and this is end. Then I can simply return my result. Then I can return the result. Return my result. Okay, this is the how is ends. I'll explain the problem, I'll explain the thing, but if you don't want to understand this thing, you can skip right now. So that's why I'm talking about time complexity first, then I will focus on this power. So if you go here adjacency list, this is nothing but big O of n minus 1, because n minus 1 edges are there, so it is big O of n minus 1 is nothing but big O of n. Okay, I'm considering in the map approaching like what should I say, in the map accessing one element is big of one element, so I'm like removing that thing. This big of one, I'm considering like accessing one element as big of one. It could be big of n as well, or instead of map you can do one thing, you can use one list of list as well. Instead of map you can use list of list, that you can do. Okay, forget that. Now this one DFS, this will take big of n times here. uh, I am iterating each index. After that, each node. So each node I am checking that for its following nodes. So this will be big of one only. It will be big of one. So sorry, big of one, not big of n. Total is big of n. This DFS. For this one, it is nothing but big of log n. I will explain this how it becomes big of log n. You can think this is big of log n. So this power is big of log n. log n. So what is the total time complexity? It is big of n plus log n. Log n, that is nothing but big O of n. Big O of n. So time complexity is nothing but big O of n. Okay. Space complexity, it is nothing but I am taking one extra space for adjacent list, that is also big O of n. So this is the approach to solve the problem. Hope you get it. Okay, now let's focus about this one, like how I calculate this power of this thing. Okay. Okay, let's now I am going to explain. If you are done with this, like you don't want to understand this power formula, then you can leave this video and you can like enjoy. What should I say? Then okay, let's see the power formula. Let's take an example and I'll let you explain it. Let's say I'm doing 3 to the power 5. This means what? 3 times, like 5 times 3, I have to multiply. Correct? Okay. So if I see what is the 5, if I explain the digit 101, isn't it? So this is my 5. So instead of doing like this thing is nothing but my 5, correct? So I can do what? What is the position bit index? 0th index, 1 index, 2nd index, correct? So 3 to the power 5 can be written as 3 to the power 4 plus 3 to the power 1. That can be done. So how I am getting 3 to the power 4, 3 to the power 1? You can say why I am not writing 3 to the power 3 plus 3 to the power 2. Why I am writing this specific pattern? Why? See this index. This now coming to this here. What is 0? If I use 2 to the power 0, it is nothing but 1. And that's why I am writing this 1. I am writing 3 to the power 1. For 0, it is if it is 0, I will not consider. If it is 1 only, I will consider. Correct? For let's say this one, for this one, let's say this one is nothing but 2 to the power 2 index. I am taking this index. For this one, index becomes 2 to the power 2. So 2 to the power 2, 2 to the power 2, it becomes what? 4. So that's why I am getting 3 to the power 4. That's why I am getting 3 to the power 4 plus 3 to the power sorry, not plus, sorry, my bad, not plus, 3 to the power 4 into 3 to the power 1. Okay, so here also it is not plus, it should be into. So into 3 to the power 1. So if I do that, then also it is 3 to the power 5, right? So now that's why I am doing some calculation. Let's give another example. Let's say 1 0 0 1 and 1. So what is the index? What is the value of this? Let's say. So why I am taking this one? This is nothing but 0 2 4 8 16. Let's say 18. 3 to the power 18 I want to calculate. So to calculate 3 to the power 18, I can calculate 3 to the power 16 into 3 to the power 2. I can do this thing and I can calculate 3 to the power 18. So now what can I do? I can, let's say I am now 18. This is nothing but 18. This is a binary representation of 18. So calculate 18. Now I do index wise. So index wise I am iterating, one iterating, I am doing that way. So earlier the index is 0th index, I am coming for last digit, last binary digit. So that's why it is 1. So it is 1 and it is 0. So 1 and it is 0. Like if when it is 1, I will do what? Whenever it is 1, my result I will store in the result. The result will be initially 1. I will initially 1. Whenever I am getting in the 18, 18 is my exponential or x to the power y I am going to calculate. This y is nothing but my 18. So now I will, for 18, for this y I will represent the binary number. So that's what I get, this binary number. Now in the binary number I will iterate from last digit to the first digit. From the last digit to the first digit I will iterate. So iterate. If that current bit place is 1, if current bit place is 1, that time I am take 0, that index of the bit. Okay, I know it's a very kind of confusing, but this is one approach. That is this one observation. This is one approach. You can calculate the power. So I'll take this one and I'll do what? Result into the base into that power. So it is 0. That's why it is I am into 0. Next, say now let's iterate and let's give an example. So result is by default 1 for case. Now my index is 0 here. My current position is result is current, so 1. Let me explain. So first I am starting from here, zeroth index. In the zeroth index I am getting 1. So 1 I am getting. In this one, what is the index position of this one? This is 0. So I'll add what is my base into that power. Okay, now I am coming this position. It is 1. Okay, it is 1. So I will do. So oh sorry, it is not 18. It is actually 19. Why I am saying is 18. So it is 19. So 3 to the power 19. So 19 means 3 to the power 16 into 2 into 3. Okay. So this thing, so 3 to the power 0, like I'm getting trading for this one, done. Now I am coming to here. So it is nothing but 3. Okay, wait a minute. What I am doing? It is not index. Index is nothing but my 0, 1, 2, 3, and 4. Okay. This is my index. Okay. Now what I can do, 3 to the power 19 I can say 3 to the power 16, then 3 square and 3. How can I going to get this thing? Okay, so whenever I get is 1, I will do what? I take the index, I will take the index and I will do calculate this thing, 2 to the power 0. So again let me iterate, then we will understand. Then I come in this one position. What is the index position is 1. So I will do into 3 to the power 2 and 1. Then I will come at index position here. Then it is 0. If it is 0, I will not do anything. Then it will come here. It will 0, I will not do anything. Then I will come in here. I will do again 3 into 2 to the power that index position. So this is nothing but 1 into 3 to the power 2 to the power 0 is nothing but 1. So that's why single 3. 2 to the power 1 is 2. That's why 2. And 3 to the power 4 is 16. This is how we can calculate. And we can directly multiply and get 3 to the power 19. This is how we can calculate. Hope you get this problem. Okay, so how are we are going to check? Okay, so let's see how we are going to check that thing. First I'll write a while loop. So I don't know the index or bit position of that. Okay, so this is to the I am going to calculate my to the power 19. So my power in the power function, I pass 3 and 19, so it becomes x and it becomes y. So do you need to convert into the this integer to binary, that y integer to binary, and do I need to convert? So here I am saying I am converting, but actually don't need to convert. I can calculate a different way. How could I calculate? So that's why it is coming here. That's why I am initializing two variables. One is base, that is nothing but my x, that is 3, and another is my result, that is 1, that is 1. Then what I am going to do, I am also need a mod value. So mod is nothing but 10 to the power 9 plus 1, that is my mod value. Fine. Now what I am going to do, now I am writing my while loop. While this y is greater than 0, I will do this thing. While this y is greater than 0, and this is similar to the while y. So this line is actually similar to, you can write this way or you can write while y. I have written that earlier. Okay, that's what I am doing. So this is what I am doing, while y or greater than 0. Now what I need actually in this y, what I need, I get this is my last index bit, like last bit of the y, correct? Y, last bit of the y. So I have to check whether the last bit is set or not. I am just only consider of the last bit. I don't actually know what is my other bits. I am not cared about this thing. I only care about last one, correct? So y is there. Y is nothing but 19, and we know like 10011. I am not converting into the binary, okay, but it is the actual case. This is the actual binary representation of 19, correct? We do what? We will check my last bit is set or not. If last bit is set, then I will do the part. If it is not set, then I will not do this thing that I told you. If it is 0, then I am not adding in something into my calculation, okay, in the result. If it is If it is 1, then only I will add or multiply something into my result. So that's why I check. How to check the last bit is set or not? One bit manipulation formula is there. If y and 1. If it is written 1, that means last bit is set. If it is written 0, that means last bit is not set. This is one formula. You can remember. To check it is the last bit is set or not. This is a formula. We can check it. Okay. So, or this is actually not a last bit is set or not. The thing is actually, if I explain the problem is this formula used to check whether this y is odd or not, odd or even. Think if the last bit is set, then only my actual number is odd. Okay. If it is 0, then my actual number is even. Remember this thing. These are the observations. If my last bit is 1, then the actual number is 1. Sorry, odd. If last bit is 0, this one is actually even. And this thing, this y greater than 1, this thing is used to check. This thing is used. That means this is a y is a odd or number or even number. If it is return me 1, that means it's a odd number. If it is return me 0, that's mean an even number. So that's why I am doing this thing. If it is return me 1, that means 1. Y is a odd number, and y odd number means last bit is set. Hope you are getting this problem. So that's why I said it is a very tricky thing. So that's why I'm explaining. And this is done. Okay, so this is how we can check the last bit is set or not. If last bit is set, what I am going to do, I am going to say like what I was writing in there. I'm writing result equals to, you can say result into, I'm calculating this one. So you are saying what? I am calculating base, what is current base to the power, 2 to the power my there's index position, 2 to the power my index position 0, 1, 2, 3, 4, correct? Or that like that I can say. But here I am not going to do that thing. Okay, I will simply write this thing base. But I have to update the base. I have to update the base eventually. I have to update the base eventually. How could I update the base? Okay, let's see now. Update the base, and after that I will do into base. But see here, I am doing only this. Now you can argue like I am writing this one, but I am writing into b. Why I am writing into b? I will update the base eventually. See here, for the first index, first now I am checking for the 0th index, right? 0th index, what will be the case? 2 to the power 0, nothing but 1. So nothing but 1. So that means this is nothing but my base 2 to the power 0. That 2 to the power, like whatever my base into 2 to the power 0, 2 to the 0 is nothing but 1. So base to the power 1, that means but my base. So I can simply right now I can do the base. For the next set, for the next time, my base becomes 1 again. So now the base becomes 1. The next time base becomes 2 to the power 1 into 1, right? That is my 2. So base becomes 2 to the power into base to the power 2 to the power 1. That is nothing but base to the power 2. That is base square. So what I will do, after I am done this calculation, after I done this calculation, I will update the base. Base will be base in earlier base into base. Why I am doing this? Earlier base into base. See this one, 1 0 1 1 0 0 1 1. So this is 0th index, this is 1 index, this is 2 index, 3 index, 4 index. If I do 2 to the power calculation, 2 to the power 0 is 1, 2 to the power 2 is 2, 2 to the power 3 is 4, 2 to the power 3 is 8, 2 to the power 8 is 16. So 2 to the power 4 is 16, 2 to the power 3 is 8, 2 to the power 4 is 16. This is like 2 to the power power. So that's why I'm calculating like 3 into, let's say, base into 2 to the power index, then again 2 into 2 to the power, let's say 1, then again into 2 into 2 to the power 4. That's why I'm calculating. But instead of calculating that, I can directly find the base. How can I directly find the base? See this one. Like earlier by base 1, this is nothing but, for this case, I do what? I write 2 to the power, sorry, for this example, my base is 3, 3 to the power 1. For this one, it should be 3 to the power my 4, 3 to the power 2, sorry, 3 to the power 2. For this case, it will be 3 to the power minus 16. Correct? I need this one. So this is nothing but 3 square. So, and this place will be what? 3 to the power 3. This place will be what? 3 to the power, sorry, 3 to the power 4. And this place will be 3 to the power minus 8. This will be my this place. If I, and this is my this places, all the places, like from 0th place, it means 2 to the power 1. 1 plus 3 square. Second place 2 to the power 4. In this place 2 to the power 3, that means 8, and this is 2 to the power 16. But my thing, which 3's are contributing? Only which have the only one. These, whatever the zeros are there, these are not contributing. Right? Now, instead of calculating this one square and this kind of more complex, we can simply, for this, I'm checking for this index, right? For this one. For this one, 3 is nothing but simple 3. For this one, this value will be 3 into 3, then square. So that's why base into base. Then whenever I come this one, this base, again base will be 3 square. So 3 square into 3 square is 3 power 4. For this one, this place it will be 3 into 4 into 3 into 4, 3 into 8. So that's why I'm doing base into base. See this one. This place is nothing but square of this place. This place is nothing but square of this place. This thing is nothing but square of this thing. This thing is nothing but square of this thing. Like, correct? That's why I'm calculating. So that's why base into base into base. Like base equals to, I'm upgrading your base it. And the next time, let's say next time I will get this one. This one, that time base is upgraded by square. So that time result will be directly upgraded by 3 to the power square, right? So if I right now given another kind of dry run, let's say result is nothing but my 1. I am currently at this 1. For this one, it is contributing 1. So base is nothing but 3 earlier. So it will do result into base. Result into base becomes 3. Now I'll do base equals to base into base. So base becomes 3 square. Base becomes 3 square. So it is also 1. It is also 1. So that's why it becomes, I will multiply 3 square. Now again, I will update the base by 3 square, 3 to the power 4. But here when I come at in this index, it will not contribute because it is 0, not contribute. So that's why I'm not adding to the result, but I will update the base. Again, base equals to base into base. So that is nothing but 3 to the power 8. 3 to the power 8. Okay. Now this is done. Now 3 to the power 8. I am in this position. Is it contribute? Will it contribute? No, it will not contribute. So it will become 3 to the power 16. 3 to the power 16. Now when I come this one, now this is 1. This will contribute. Now it will be 3 to the power 16. I will add into it. Now this will becomes again 3 to the power 32. But doesn't matter what it becomes because I am out of the loop. Like my digit are out of n. So that's why it is done. So this is my calculation. Correct? Hope you get it. Now the thing is, now my next question is, this is the dry run. I understand this is a dry run, but the problem is, like, how could I get to the next index? How could I get this index from index? I'm currently at this index, that's what I'm getting. Now I need this one, right? I don't need this one. I don't need this one, doesn't matter. So let's say whenever I am at 10011, I'm at index, whenever I'm done, I don't care about this thing. I'm only care about the rest of the digit, right? Then whenever I'm checking this one, I'm done with this. Then I will care about this 3 digit, right? This is what we can do. That means what? That 10011. First is first thing I care about this one. Then my digit can become this one. I care about this one. This becomes this one. Then I care about this one. Then this one I care about this one. Then this one I care about this one. And this it is 0. This is nothing but my right shift operation. This is nothing but my right shift operation. Correct. So I simply write here one right shift operation. I can simply write right shift operation. So this y will be updated. Y will be right shift of y. Y will be y right shift of 1 line. And it is done. Now it is done. Now the one thing will appear. One problem will appear still now. The problem is I can return return my result. The problem is I have to modulo it, because see this one, this could be a huge number because it is exponentially incrementing. It is becomes 3, then 3 square, then 3 to the power 4, then 3 to the power 8, then 3 to the power 16. This exponentially it is going. So that's why I have to do modulo mod. So the thing is, you can directly write mod here. So instead of that, you can write mod here. Mod is a special kind of thing. Even if you add mod any other place, it will not change the uh, output. So I can write the mod in any places in here. So this is the mod. You can write mod as well here as well. You can write that whatever my y equals to mod as well. Doesn't matter. Okay, so that's why I am writing mod in each and every step and return this result. This is how you can calculate this function, this power function, this power function. This is how you can calculate. So this is one thing. Now another thing. Now let's calculate the time complexity of this. This time complexity is nothing but number of bit set present in my that exponential. Let's say, let me give the formal definition here as well. Let's say power, I am calculating x comma y, I am calculating that. Now this is depend on the length of y. Length of y, length of y is nothing but this, my number of bits of y. Okay, that is number of bits of y. So I am iterating each bit. So that is nothing but log of n, log of y actually. This is nothing but my log of y. Okay, that's why the function y could be at most big of n, log 10 to the power n. So that's why I'm taking log of n, log of n. Y could be the case. Y could be the process. N could be the 10 to the power 5, right? So y could be the approach 10 to the power 5. So that's why it is taking log of y. But the function of this problem is nothing but log of y. It is a time complexity of this function. Because I'm iterating each bit, number of bit present in this. This is a formula actually. This is the formula, number of bit present in this y. So this is why I'm this big of y. Okay. So hope you get it. And actually, the one thing I did a mistake here. The mistake actually here. This function is actually time complexity is big of y actually, but at most like it is nothing but time complexity is not big of n, it is big of y. But at the worst case, y could be big of y could be equals to, at the worst case y could be y, it is like, so at the worst case y could be n. That's why it is big of log n. N is the number of edges or number of nodes present in the tree. Okay, it's a very long video, I know, but hope you got the concept of this problem. And as always, if you find any mistake in this video, please let me know so that I can rectify. And if you find any useful information on this topic, also let me know so that I can learn. Thank you. Bye bye.